All right, it's time for chapter 4. Time flies, doesn't it? Before we get going, I got a little too much sun on my face this weekend, and I hope that doesn't distract you as you work your way through this. But let's just pick up these pieces and go. All right, this is about corresponding parts in a congruence. We know what the word congruent means, right? Hope we do. When two figures have the same size and shape, they are called congruent. When two figures are congruent, that means that they have the exact same size and shape. They can, if you slide them together, they can actually be right on top of each other. Sometimes you have to flip them. You see how this one's backward. You have to flip it over for it to be on top of the other. This one you'd have to turn it, rotate it around. But they're still congruent. They have the same size and shape. And when we're talking about congruent polygons, we talk about their corresponding parts. Corresponding means they match or agree exactly is the definition of what corresponding means. So X, this vertex over here, corresponds with vertex Y over here. The A of this polygon corresponds with P. So we can make all of these statements. We can talk about points corresponding, angles corresponding, segments, the sides corresponding. AX corresponds with PY. And we can use those exactly. And we can even say this polygon ACBX corresponds with PRQY. So over here we got the corresponding, or we have congruent triangles. What are the corresponding angles? What corresponds with D? Well, we have to be careful here because nothing's really marked, but we have the longer side here and the shorter side here, so longer side and shorter side. D is kind of longer and medium, so what's the longer and medium here? It would be F. But these are the pieces that correspond. The longer side goes with the longer side, shorter side with the shorter side, etc. So angle D corresponds with F, T with angle R, angle J with angle C, etc. And then we can talk about the corresponding sides as well. Okay? Now, we start talking about congruent triangles, and this applies to polygons. Let's go ahead and talk about that. Two polygons or triangles are congruent if and only if their vertices can be matched up so that corresponding parts of the triangle are congruent. So the corresponding parts have to be congruent for there to be congruent polygons. Let's look at this example. If this polygon, that's a pentagon, ABCDE over here, is congruent with PQRST, well, let's mark them appropriately. Well, this short side that's making up this right angle over here, DE and ST, those two segments got to be corresponding. Let's mark those with 1. We'll just go around and mark the next segment with 2, and then with 3, and then with 4, and then with 5. Remember, the markings is how we'll mark that things are congruent. And we can do the same things with the angles. Which piece is going to correspond with A? P. P does. And so we can name this different ways. Up here it's named ABCDE is congruent with PQRST. But we could start with D, DEABC. What's that going to be congruent with? Well, we'd have to just put the letters of the second one in the same way. So what this should mean is, if you just look at two consecutive letters, AB, that's side AB over here, it should correspond with, that's the third and the fourth spot, the third and the fourth spot over here, PQ. So AB is congruent with PQ. And so how you name those, that has to match up when we're talking about congruency. So the order. How you name the first one doesn't matter, but it has to. The second one has to correspond with it. So the sides and the vertices all match up. So look at these guys down here in the bottom. 1, 2, 3, 4. Go ahead and try it. Go ahead and do it. Pause the video and see if you can name these. Okay. There are other answers. I just named 2 because they told me to on these, but so as long as you have those things corresponding appropriately and you're naming those polygons correctly, it's fine. Remember, naming polygons, it doesn't matter which letter you start with as long as you go around in whatever direction you start, you just keep going around consecutively. So the definition of corresponding triangles, or polygons for that matter, is an if and only if statement. It's a biconditional. So it means we can go both ways. So if triangle LMN is congruent with triangle RST, then we can conclude the following, that all of these angles and all these sides are congruent with each other. And we can also say, we can flip it around and say, all right, if all of these sides are congruent, then we know the triangles are congruent. So the first way that we are going to establish that we have congruency is to say that all of the pieces and parts, all of the angles and all the sides of that polygon are congruent. All right, so that was that. Look at 5 through 12 down here and see if you can identify the congruent. Now we're not calling them corresponding now. Now we're calling them congruent parts. Pause the video and give it a shot. Okay, here are answers to the left-hand side. I color-coded those to try to make it easier. So did you get that W and A correspond with each other? F and Y correspond with each other? And then this makes it easier. But I want to show you something. I want to try something. Can you do this from only the name? Let's take a look at what it would look like. So the diagram's gone here. But can't we just look at this up here and say that what goes with AF, what corresponds with that would be W and Y. Do you see how that would work? And then set what corresponds or what is congruent with YX. That would be YX is here. Well, look over here. What corresponds with it? Segment FB, and etc. So we don't really, if we have a statement of congruence, we really don't need the diagram to line up all those corresponding parts. We can literally do this with our, well, that's not true. I was going to say we could do it with our eyes closed. We need our eyes, but we don't need diagrams. Write that. I don't need diagrams down below 11 and 12. Okay, the last piece of this puzzle is to introduce you to this abbreviation. Well, first of all, when the definition of congruent triangles is used to justify a statement, in other words, the reason that we'll use, we'll say, how did you know that those angles are congruent? Well, you would say they were corresponding parts of congruent triangles. That's a mouthful. So the phrase or that we will abbreviate, we will say CPCTC. You are welcome to write out every time corresponding parts of congruent triangles are congruent. Or you can use this phrase CPCTC. Go ahead and memorize it. CPCTC. You are going to have to know it. All right, go ahead and pause the video one last time and see if you can answer these last questions, 13 through 24. Did you figure out here that we could also say the corresponding parts of these triangles, BD is congruent with itself? That's the reflexive property as well. So it's CPCTC, and it's corresponding parts of those congruent triangles. These are answers to the last piece of this. This one is interesting because if you flip this around, you have the same shape. So that's how we could name this thing several different ways. FEHG is the same as GHEF. All those corresponding parts would be the same. So we can end up naming those different ways. All right, you people have looked awfully tired. I hope you get some good rest. Come to class with any questions that you have, or before class. I'm happy to answer those questions that you have. Okay, bye.